Earth is the place we call home. It's where we work, eat, sleep, and go about our daily lives. But how well do we really know it? We like to think of Earth as the blue marble, a stable, temperate world hospitable to life. But that's really just a snapshot of a dynamic and evolving planet. If we zoom out on the cosmic timeline, we discover that our home would have been unrecognizable to us at most other times in its history. So, let's see if we can reconstruct what Earth might have looked like in the distant past. Let's imagine that alien scientists, who have never seen Earth as it is today, visited at various stages in its development. Depending on when these visitors arrived, they would have formed completely different ideas about the kind of planet Earth was. What would they have seen 4.5 billion years ago, 2 billion years ago, half a billion years ago? I'm Alex McColgan and you're watching Astrum. Join me today as we recreate Earth's ancient past and imagine what the planet might have looked like at various points in time. Now, before we start, a little disclaimer. To answer these questions, we'll need to draw on some models that not all our scientists agree on. Traveling into the extremely distant past always carries some error bars. Some of the science we're pretty sure about, other things are still being debated. So, as we indulge our imagination, let's keep in mind that some of these claims are still being developed and rigorously questioned, as they should be. But to the best of our current knowledge, this is what our planet could have been like. As long as we're going into the past, we might as well go way back. Let's start 4.5 billion years ago. It's not the very beginning, but pretty close to it. At this time, the Earth is basically a hot, viscous ball of molten rock, and I doubt our alien visitors will want to hang around for very long. The Earth is still young, not even 100 million years old yet, which in planetary terms is an infant. Earth's thin atmosphere is made mostly of hydrogen and helium, most of which is stripped by the solar wind, since the Earth hasn't yet formed a magnetic field. As a result, the young planet has little protection from the sun's cosmic rays, and the planet is a hotbed of radiation. Earth is also constantly being bombarded with asteroids and comets, which add to its mass, a process called accretion. Just imagine a big ball of chewing gum that you keep adding to with fresh wads of gum, and you'll get the idea. So not only is the young Earth hot and gooey, it's also growing. But these are not the only impacts the planet has to contend with. In the recent past, there was a cataclysmic event in which a protoplanet collided with the Earth, resulting in the formation of our moon. If our alien visitors were to see Earth in this state, would they see its potential? I'm unsure I would at this stage. But despite these ominous beginnings, the seeds of change are taking root. Riding aboard these inbound asteroids is a special compound that will play a crucial role in Earth's history: water. While not all of Earth's water comes from these meteors, scientists believe much of it does. According to this theory, hydrogen ions in the solar wind impact these meteors, ejecting oxygen atoms under their surfaces, thereby producing water. These frequent impacts seed much of the young planet's water. Then, as the planet cools, heavier elements sink towards the Earth's center, and lighter compounds, such as water, rise to the surface. Volcanic eruptions spew other gases like carbon dioxide, ammonia, and additional water vapor into the atmosphere. Eventually, all of this accumulating water vapor will lead to the formation of Earth's oceans and its mature atmosphere. So, even if Earth is a dangerous place to be at the moment, our alien visitors might see some untapped potential and come back to Earth once it's had a bit more time in the oven. Let's imagine that the scientists returned to Earth 2.5 billion years ago to see if anything has changed. 2 billion years have passed, and instead of a molten planet, they find what our scientists call the pale orange dot. Earth has developed a solid crust and magnetic field, which has retained a methane-rich atmosphere with a distinct pale orange haze, very much like Saturn's Titan. Earth also has vast oceans of liquid water formed from rainfall. Looking upward, our alien scientists see a terrifyingly huge moon overhead, far closer than it is today. Here's a fun fact. The moon has slowly been drifting away from Earth for the past 2.5 billion years and is still moving away from us at the rate of 3.8 centimeters per year. This drift will eventually stop, but not for another several billion years. But 2.5 billion years ago, the moon is much, much closer, and this proximity leads to far stronger tidal forces in the oceans. While this snapshot of Earth is probably more Earth-like than the previous snapshot, to me it almost feels more alien than before. Earth must have looked like a barren dream world, a lot closer to a surreal Salvador Dali painting than the teeming planet we know today. Being experienced in the field of astrobiology, our alien scientists take some blue-green water samples and find the cause of this orange haze, photosynthesizing bacteria called cyanobacteria. They are excited to find that Earth has developed life. These primitive bacteria are living in communities in shallow water, which in turn have released oxygen into the atmosphere in an event called the Great Oxidation. As part of this transformation, the Earth now has a protective ozone layer, which shields life from the most harmful effects of solar radiation. The bacteria are also producing unusual rock structures called stromatolites, similar to these modern ones located in Western Australia's Shark Bay. Cyanobacteria form stromatolites by cementing grains of sediment together with biofilms, or, to put it in another way, microbial slime. Stromatolites are one of the biosignatures that astrobiologists say we should be looking for on other planets, although they can have non-biological causes, so you have to look at them on a microscopic scale to be sure. Without any competitors, the cyanobacteria reign supreme. Using solar energy, they are converting carbon dioxide and water into nutrients, seeding the atmosphere with oxygen as a byproduct. Bacteria are now the uncontested rulers of planet Earth, and they have permanently altered their atmosphere in ways that make our current way of life possible. Enthusiastic for Earth's future, our alien scientists decide to come back to Earth 650 million years ago. And boy, what a difference 1.9 billion years makes. The planet is now in its cryogenian period, at a time scientists call Snowball Earth. According to these models, Earth is completely frozen over. Think of the last Pleistocene ice age, only a lot colder. In fact, all of the Earth's surface and half of its total ocean water are frozen solid. The Earth has become so cold that temperatures at the equator are similar to those in modern-day Antarctica. While the scientists aren't sure what triggered this downshift in global temperatures, some theories include a major volcanic eruption that spewed ash into the atmosphere, a vast reduction in greenhouse gases due to photosynthesizing life forms, and Milankovitch cycles, which we've previously covered on this channel. Of course, it was quite likely a combination of factors that amplified this global cooling. Interestingly enough, underneath all this glacial ice is a single supercontinent called Pannotia, centered on the South Pole. However, given the vast glacial cover, our alien visitors are having trouble discerning land from ocean. As a side note, don't confuse this supercontinent with Pangaea. Plate tectonics will eventually break apart Pannotia and reform that later supercontinent in a few 100 million years. But let's not get ahead of ourselves. Our space visitors land and wander around the vast, endless glaciers, amazed that this frozen landscape was once covered in molten rock. At first, they think the harsh climate might have wiped out Earth's fledgling life, but that life has proven remarkably resilient. Cyanobacteria remain in the ocean, perhaps clustered around hot hydrothermal vents, much like the black smokers that are currently at the mid-Atlantic ridge. There are also newly evolved microbial lifeforms, such as red algae. Complex, multicellular life remains elusive, but the fact that life has found a way to survive the planet's harshest freezing events so far is a testament to its staying power. At this point, I'd like to imagine our alien visitors having an argument among themselves. The youngest and most temperamental of the group is having a tantrum. First a lava ball, then a barren bacterial playground, and now a ball of ice, it exclaims. Why do we keep coming back here? But the eldest of the group puts an arm, tentacle, or articulated limb of our preference around its younger comrade. Patience, the wise alien tourist says to its impertinent partner. I have a feeling this planet is in for some major shakeups. Let's come back in another few 100 million years. I think it will be worth the trip. So, giving the planet time to change, our alien scientists decide to come back during the Devonian period 360 million years ago, and they are shocked by what they see. The planet has thawed completely, with temperatures generally warmer than those of the present day. Scientists estimate that the tropical sea surface temperatures range from 30 degrees Celsius to 21 degrees Celsius later in the Devonian, a temperature drop that coincides with diminishing CO2 levels due to increasing plant growth. The supercontinent has broken up and formed multiple continents, the largest of which is Gondwana, covering the South Pole and much of the Southern Hemisphere. Gondwana incorporates much of what is modern-day Africa, South America, Antarctica, Australia, and India, so it's pretty big. But the most dramatic change our visitors notice is that life has already undergone the Cambrian explosion, a rapid expansion of biological diversity that filled the seas with all sorts of complex life. The oceans are now teeming with trilobites, clam-like brachiopods, and complex marine vertebrates, such as fish. Among the more fearsome specimens are Dunkleosteus, a massive, armored fish 10 meters in length, and Titanichthys, another giant with a taste for smaller prey, like krill-like zooplankton. Given the presence of these fish that look like great white sharks crossed with armored submarines, our alien scientists decide not to go for a swim, despite the invitingly warm waters. Meanwhile, plants have completely transformed what was once barren continental crust. With no large herbivores in existence, vegetation grows unchecked into dense, sprawling forest, which have produced a layer of stable, nutrient-rich topsoil. But these trees would look very unusual to us. They are vascular plants, related to today's ferns and some conifers. There is also an enormous tree-like fungus called prototaxites, which stands some 8 meters tall. Very likely, these mysterious tree-like structures are fruiting bodies of far larger subterranean organisms which haven't been preserved. A few marine species have even evolved limbs and are beginning to walk on land, such as Ichthyostega, a rather charming four-legged vertebrate that looks like a modern amphibian, whose stout limbs and lungs allow it to navigate swamp-like habitats. As our alien visitors leave the Devonian period Earth, they finally have a sense of the ecological diversity and temperate climate that will follow. The once molten planet turned pale orange dot turned giant snowball now somewhat resembles the blue marble we know today. Of course, other big changes are yet to happen. A mass extinction event will soon decimate marine life and eventually lead to greater complexity among the land animals that adapt. Temperatures will again plunge, setting off the late Paleozoic Ice Age before rebounding to warmer temperatures again, and complex life will continue evolving in remarkable ways. Among the new species will be amphibians and some giant reptiles you might have heard about called dinosaurs. I wonder when our alien scientists will visit next. How far in the future will they be? Will they meet us? Will they exchange some intergalactic travel tips with our future descendants? I guess we'll have to leave that chapter of Earth Saga for another day. I hope you enjoyed this journey of planetary evolution. Are you interested in hearing some more about Earth's past in future episodes? If so, let me know in the comments. The Earth is 4.54 billion years old, plus or minus 50 million years. That's a lot of birthdays. In that time, Earth has undergone some pretty incredible changes. In a recent episode, we covered 4.2 billion years of that history, which saw the Earth transform from a molten ball of lava to a pale orange wasteland, to a giant snowball, to a flourishing tropical world. But Earth Saga is like a TV drama that keeps taking twists and turns, with some of the most incredible stuff happening in the last 300 million years. So, for those of you that were disappointed we didn't cover dinosaurs in part 1, well, you might want to stick around. And for anyone just tuning in, here's our premise. Imagine that alien scientists visited Earth at various stages in its development. What kind of planet would they find? I'm Alex McColgan and you're watching Astrum. Join me today as we continue Earth Saga and imagine how the planet might have looked in its ancient past. First, a reminder. To answer these questions, we'll draw on models that not all scientists agree on, although the job gets easier when our timeline is in the millions rather than billions of years. Not all of the science is settled, and some of these models are still being debated, but to the best of our current knowledge, this is what our planet could have been like. Now, back to the story. Our intrepid alien scientists are fresh off their exciting trip to Earth during the Devonian period, and are pretty excited about the direction things are headed. Obviously, they need to see what happens next. So they make a return trip 280 million years ago. Earth is now in its early Permian period. The biggest geographical change is that the continents of Euramerica and Gondwana have combined into a single landmass called Pangaea. The collision of these continents, called the Variscan orogeny, unleashes powerful tectonic forces that create a mountain range called the Central Pangaean Mountains. How tall are they? Well, Mount Everest is in the right ballpark, as this range is comparable in size to the modern Himalayas. In fact, they are so tall that they have a profound effect on the climate of Pangaea. The Central Pangaean Mountains lie just beneath the equatorial rainy belt, and our scientists quickly discover the impact of these giant mountains on the entire continent. South of the range, it is a mega monsoon climate. However, there is a flip side to all this rain. The mountain range in turn casts a rain shadow to the north, which creates a huge desert in Pangaea's interior. Basically, when air travels over tall mountains, it moves upward and cools, causing precipitation, so that by the time it crosses the mountains, the air is pretty arid. We see this effect today in the Gobi Desert, which is located in the rain shadow of the Himalayas. Pangaea's formation is a great example of how plate tectonics not only impact the world's land masses and oceans, but its weather as well. Yet, there are also other factors shaking up the world's climate. During the early Permian, the Earth is still in the latter days of an ice age dating back tens of millions of years, an event known as the Late Paleozoic Ice House. Our leading theory for this cooling is that the explosion of plant life during the Carboniferous raised Earth's oxygen levels and diminished its CO2, leading to a reduction in the greenhouse effect, with Milankovitch cycles also likely playing a role. During the Late Paleozoic Ice House, vast glaciers built up at the poles and in the higher elevations. Yet, by the early Permian, the planet has begun entering a warming trend. The polar ice caps are retreating, but glaciers remain in most of the high elevation mountain ranges. So, between the climate disruptions caused by Pangaea and the cooler than normal but warming global temperatures, life forms on Earth have had a lot of adjustments to make. Since our aliens last visited, the formation of Pangaea has produced a vast superocean called the Panthalassic, or Universal Sea, as well as a smaller ocean called the Paleotethys. The Panthalassic is so big it occupies almost 70% of Earth's surface. To gather more information, and, if possible, see what's down there with their own eyes, our aliens enter a submersible and dive in. As it turns out, the safety provided by said vehicle is much needed. While harmless trilobites and nautili remain in abundance, Earth's oceans have had some terrifying new inhabitants. Among them is one of the strangest predators ever to patrol the watery depths, Helicoprion, an 8-meter-long shark-like fish with a wall of teeth in its lower jaw resembling a buzzsaw. Most likely this wall is an adaptation for tearing apart and sucking soft-bodied prey. Our aliens have seen some strange creatures during their interstellar travels, but this is definitely one of the strangest. And honestly, Helicoprion would look utterly alien to us too. I personally have always dreamed of a day when humans discover extraterrestrial life, but until that day comes, our best resource for understanding how life can evolve under various conditions is Earth's own fossil record. Earth was a different planet back then. In our own solar system, moons such as Europa, Ganymede and Enceladus may have subsurface oceans suitable for strange life forms. Meanwhile, on land, insects have begun to flex some serious muscle. There are all sorts of beetles, including Permocupidae and Meganisotera, an extinct order of giant dragonflies. Just imagine a dragonfly with a wingspan about the size of common seagulls and you'll have the idea. Another frankly bizarre newcomer is Diplocaulus, an early amphibian with a boomerang-shaped head. Look at how fascinating these Earth aliens are, I can hear our extraterrestrial xenozoologists say. But by far, the most interesting quadruped of the early Permian is the Dimetrodon. Although it is often mistaken for a dinosaur in the popular imagination, this 2 to 4 meter sail-backed predator is actually a synapsid, more closely related to modern mammals than reptiles. Believe it or not, the sail could be an adaptation that predates the transition from exotherms, or animals that absorb heat from their environment, to endotherms, which regulate temperature internally. You know, warm-blooded creatures like you and me. Dimetrodon's sail contains a network of blood vessels, which allows it to raise its temperature more quickly in sunlight, an early step towards temperature regulation. On a planet experiencing all kinds of climatic changes, this ability to regulate temperature would certainly be advantageous. It's a wonderful illustration of how much living organisms can and must change in order to survive. Our planet's climate is like a complex system full of inputs with a biosphere as corresponding outputs. Planets like ours dictate what sort of life can exist on them. And interestingly, as a planet changes over time, the type of life it can support also changes. Impressed by Earth's development, our alien scientists decide to return in another 100 million years. Unbeknownst to them, they will miss the largest extinction event in Earth's history. And I'm not talking about the asteroid that eventually killed off the dinosaurs. A much more catastrophic extinction takes place around 252 million years ago, called the Permian-Triassic extinction event. Our leading theory is that volcanic eruptions release a huge amount of CO2 into the atmosphere, which raise global temperatures and make the oceans more acidic. This catastrophic event eradicates about 70% of terrestrial vertebrate species and 80% of all marine species, a mass die-off unmatched by any other in the history of the planet. Yet, as devastating as this is in the short term, it would eventually clear the field for a whole lot of evolutionary diversification during the Triassic and Jurassic. And chief among the beneficiaries is a group of reptiles that would one day rule the planet: dinosaurs. Our alien scientists returned to Earth during the late Jurassic period, 150 million years ago. Although Pangaea managed to hang around until the early Jurassic, by now it is starting to drift apart due to tectonic movements in the planet's lithosphere. The Earth is made up of about 15 to 20 tectonic plates, which are always moving toward or away from each other at a rate of around 1.5 centimeters a year, which, interestingly enough, is pretty much the same rate as our toenails grow. As plates move away from each other, they open a rift marked by outpouring basaltic lava. So, beginning around 200 million years ago, Laurasia breaks away from Gondwana, creating two smaller supercontinents. In the north, Laurasia contains modern-day North America and Eurasia. To the south, Gondwana includes modern-day South America, Africa, Australia, India, and Antarctica. A narrow body of water called the Tethys Sea is also opening up. It will one day grow into the North Atlantic Ocean as outpouring basaltic lavas at the Mid-Atlantic Ridge continue to push the landmasses farther apart. Meanwhile, in the south, Antarctica and Madagascar have begun to separate from Africa, opening up the Proto-Indian Ocean. While the continental landmasses still look quite different from how they look today, our alien visitors already have an inkling of where Earth's continental configuration is heading. The climate of the period is scorching hot. Global temperatures are 5 to 10 degrees warmer than they are today, with atmospheric CO2 levels approximately 4 times greater. What contributed to all this CO2? Very likely, the mass extinction of plants during both the Permian-Jurassic extinction event and a subsequent die-off called the End-Jurassic extinction played hefty roles. Global temperatures are so warm that ice sheets are unable to form at the poles. Instead, the poles are covered in forests, which likely experience warm summers and cool, snowy winters. With so little water locked up in glacial ice, sea levels are significantly higher than they are today, with the peak happening right around this time, about 140 meters higher. In terms of flora, gymnosperms such as conifers have become one of the most successful plant types. Some trees, like the extinct Araucaria mirabilis, represented by this extraordinarily well-preserved cone, look eerily similar to what you might find today. This is also a golden age for cycads, palm-like vegetation with woody cylindrical trunks and stiff pinnate leaves. These plants grow heartily in the late Jurassic's expansive tropical and subtropical climate zones. As our alien scientists step out of their ship, they hear an ominous rumbling. Looking over, they spot a pack of towering sauropods. Not just any sauropods either, Supersaurus, one of the most massive terrestrial animals in Earth's history, measuring up to 35 meters long and weighing 40 metric tons. Getting over their initial fright, our alien visitors realize that these Goliaths are in fact herbivorous grazers, well adapted for reaching high vegetation. But their relief is short-lived. Stalking some of the smaller sauropods is a rangy Allosaurus, a formidable species of carnivore nearly 10 meters long with dozens of needle-sharp serrated teeth. Luckily, our alien visitors escape their brush with the hungry carnosaur and decide to finish the rest of their tour from the safety of their ship. Once they're in the air, they encounter a feathered Archaeopteryx, an avian dinosaur considered to be one of the first birds. Archaeopteryx is also sharing the skies with large flocks of non-avian pterosaurs, such as Dimorphodon and the crested Pterodactylus. These winged predators are well adapted for catching smaller animals and invertebrates in their toothy, beak-like jaws. But as our alien scientists stop their expedition for lunch in one of the more sheltered forest glades, it's something small and unassuming emerging from a burrow that catches the xenozoologist's interest again. A small furry creature called Taeniolabis. Taeniolabis and other members of the extinct order Multituberculates, named after their unusual teeth, which they'd used to chew in a forward and back grinding motion, are some of the earliest mammals. And while they may look unassuming, our aliens quickly realize there's something different about them as they observe their sociability and the way that they play with one another. These little rodent-like creatures have highly developed brains, especially compared to pea-brain dinosaurs, and they are warm-blooded, with a useful adaptation called fur to keep them insulated. Little do our alien visitors know, the great descendants of these humble, scurrying creatures will one day outlive the dinosaurs and dominate the Earth. But that chapter will have to wait for a return trip by our intrepid travelers. They are worn out from the scrapes and scares of this trip, but they certainly have an idea of Earth's immense diversity and adaptability. Who knows? They may come back to finish the story another day. Welcome back to our alien tour of Earth's history, where we reconstruct what prehistoric Earth might have looked like over millions and billions of years. For those just tuning in, our premise is this. Imagine that alien scientists are visiting Earth at various stages in its development. What do they see? In part 1, our alien voyagers covered a big chunk of Earth's timeline, 4.2 billion years of it. They saw the formation of the planet, a hot, molten, swirling mess, its eventual cooling, the emergence of the first organisms, and the great oxidation event that gave Earth its modern atmosphere. They swung by in the Cambrian period to witness an explosion of species diversity across our planet, and landed in the Devonian period some 350 million years ago. In part 2, our alien scientists came back to take a more in-depth look at some of the animals that roamed our then flourishing tropical Earth some 150 million years ago. Supersaurus gave them a scare, while the furry little Taenia labis caught their eye with its playful and social disposition, while Archaeopteryx circled above. Today they revisit Earth, some 84 million years later, totally oblivious to the changes that have occurred on this now dramatically different planet. I'm Alex McColgan, and you're watching Astrum. Join me today as we explore one of the most famous events of Earth's history, the dinosaur extinction. We'll examine the two leading theories of what caused this mass extinction and what kind of impact it had on the animals who were around to witness it. For the last tens of millions of years, every time our alien friends flew over Earth, they'd seen a lush, green world run by the likes of Ceratosaurus, Barosaurus, and Eoraptor. Let's imagine our alien explorers decide to descend and collect samples of this incredible world on a certain day 66 million years ago. But first, they need to make a pit stop. They are running low on helium-3 and swing by Jupiter to fuel up. Without this source of power, their ship won't be able to take off again once they land on Earth. Tomorrow, they agree, they'll come back. When they return the next day, they double-check their GPS, or Galactic Positioning System. They must have made a mistake. There is no way the fireball covered in soot they are looking at is the same thriving planet they flew over yesterday. Our alien friends are flabbergasted. What could have happened to cause such utter devastation? The Earth they came back to is covered in raging wildfires, tsunamis up to 1 kilometer high, and immense, inescapable death. A new reality has set in, one that would consume the planet for the next couple of decades. To find out what happened, let's jump forward in time to see what our human scientists have to say on the matter. In the 1980s, two human scientists made a huge discovery. They detected the presence of a chemical element called iridium in the geological record, exactly at the point in time dinosaurs disappeared from the fossil record, also known as the Cretaceous-Paleogene or KPG boundary. Not only that, but this specific iridium ring has consistently been found at the KPG boundary in samples taken from around the world. It seemed like something deposited an immense amount of iridium all over the Earth's crust at the same time that dinosaurs went extinct. The curious thing is that iridium is usually pretty hard to come by on Earth, and these rock layers at the KPG boundary contained 200 times the amount of iridium we would normally expect to find. Can you guess where iridium is abundant? Asteroids. But if such a catastrophically large asteroid did crash down to Earth, it would leave behind a crater that would be pretty hard to miss. Well, just a few years later, the human scientists found that too. Known today as the Chicxulub crater, it lies off the coast of the Yucatan Peninsula in Mexico and spans a whopping 200 kilometers. After some testing, researchers confirmed the age of the crater as being about 66 million years old, lining it up exactly with the iridium in the KPG boundary and the disappearance of dinosaurs from the fossil record. Another core piece of evidence that supports the asteroid theory is something called tektites. They've been found in abundance in several places, with one of the most astounding discoveries coming from North Dakota, USA. Researchers found a fossilized mass grave with fish, burned tree trunks, conifer branches, mammals, mosasaur bones, insects, and the partial carcass of a triceratops, all frozen in time together along the KPG boundary. Scientists had never seen such a collection of diverse organisms in different life stages who died at the same time. And in and among all the fossils were countless tektites and microtektites. The leading theory is that they are actually pieces of molten earth crust that were shot up into the sky on impact. High in the atmosphere, they cooled into natural glass and then rained back down onto the earth in a glass shower at speeds of 160 to 300 kilometers per hour. And remember, North Dakota is 3,000 kilometers away from the impact. So let's gather this evidence together and paint a picture for our alien travelers of what could have happened to Earth while they were filling up on gas. As our extraterrestrial explorers turned their back to Earth, they might have noticed an asteroid accelerating towards the planet, getting brighter and bigger against the blackness of space. About 10 to 15 kilometers wide and traveling at 72,000 kilometers per hour, it makes contact just off the shore of the Yucatan Peninsula of modern-day Mexico. This releases an insane amount of energy all at one go, the equivalent of detonating billions of nuclear weapons at the same time. This was an earthquake felt around the globe. There's no way it went unnoticed, even by animals on the other side of the planet in modern-day Indonesia. At the impact site, the thermal radiation burns everything within a 1,500 kilometer radius. The force of the impact from the asteroid makes the Earth's crust go molten and splash up like water after a pebble has been dropped in, leaving behind a monstrous crater 25 kilometers deep and 100 kilometers wide. This causes a chain reaction of enormous tidal waves, hundreds of meters high, as the ocean is pushed back from the immense force. Meanwhile, trillions of metric tons of debris, about 60 times the mass of the asteroid, explodes up into the atmosphere. Some of this debris are chunks of molten earth crust, which, high in the atmosphere, coalesce into tektites. And inevitably, what goes up must come down. For about 15 minutes following the initial impact, Earth is covered in a torrential storm of fire rain. Falling debris heats up to hundreds of degrees Celsius as it passes through Earth's atmosphere. This sets the world on fire, burning down 70% of its forests. Vaporized material that doesn't rain down as debris, such as silicate dust from rocks, stays suspended in the atmosphere, along with unbelievable amounts of soot and carbon dioxide rising from the wildfires. If you're breathing a sigh of relief for our Indonesian dinosaur friends on the other side of the planet, don't. Like with most things, it's never the actual impact that leads to the most devastation. It's the aftermath. The buildup of gases and particle debris in the atmosphere blocks out the sun, plunging the planet into an impact winter that will last at least 15 years. With no sun, plants are unable to photosynthesize, and both terrestrial and marine food chains collapse. Earth is a totally apocalyptic version of its former glory. No wonder our alien travelers had to check their GPS. The impact this would have had on animals would have been devastating. 75% of all species are wiped out forever, making this one of the largest mass extinction events in Earth's history, second only to the Permian extinction we covered in Part 2. All the animals that exist on Earth today are descendants of the survivors of this apocalypse. Others were not so lucky. Being large is a disadvantage in an apocalypse. You need lots of food, lots of space, and lots of resources. All terrestrial and marine dinosaurs suffered greatly and eventually died out as a result. A small slither of avian dinosaurs had better luck and managed to slink through the evolutionary bottleneck into the Paleogene period. They still roam the Earth today through their direct descendants, birds. When we think of birds, we think beaks. But back in the Cretaceous days, birds came in all kinds of different, wonderful variations that we've never seen with our own eyes. Some had beaks, some didn't. Some had teeth, some didn't. While it would be foolish to credit a single trait for the survival of an entire family line, it sure seems that if you were a bird 66 million years ago, having a beak stacked the odds in your favor. We think that beaked birds had an advantage as they could dig out seeds from the ground when no other food source was available. Toward the end of the Cretaceous, beaked birds were already eating a more varied diet than their non-beaked cousins. This would have been a huge advantage when rations were scarce. After all, being a picky eater in an apocalypse isn't really a good idea. Having enough force in the gizzard to crush tough fruits and seeds, and enough flight stamina to gather food over large distances also helped with survival. Some species of mammal also managed to push through. It is thought that only mammals smaller than 10 centimeters survived, as they could hide underground where they were somewhat insulated from the lower global temperatures. Being small also meant they needed less food to survive. The platypus is an example of a mammal that coexisted with dinosaurs, survived the KPG extinction, and is still around to this day. Turtles also fared surprisingly well, although it isn't understood why. About 80% of the known turtle species made it through the KPG extinction, as did crocodiles. While we can't be 100% sure why, some ideas are that crocodiles, like beaked birds, have highly diverse diets, and they can survive without food for more than a year, thanks to their excellent energy conservation abilities. Following the catastrophe, repopulation seems to have happened very fast. If our alien scientists were to fly over Earth just 30,000 years later, they'd already see flourishing new ecosystems rising from the ashes in some parts of the planet. Maybe it was for the best that our alien crew was low on helium-3 and didn't have to witness the apocalypse firsthand. Revising our version of events, our alien friends are not convinced this is the full story. They are good scientists and better skeptics. Just because the evidence paints one picture doesn't mean it can't also paint another. Indeed, that is the exact conundrum we Homo sapiens find ourselves in now. While many human scientists hold firmly to the asteroid theory, others think differently. Let's rewind the tape and re-examine the evidence. The initial clue that started all this asteroid business is that pesky element iridium. While it is present in asteroids, it is also present in another key place, the Earth's core. This gives weight to another popular theory, that crazy strong volcanic eruptions could be the culprit behind the mass extinction instead. In this scenario, the world would still be covered by a blanket of smoke, soot and debris, tektites would rain down, and the sun would be blocked out for years, causing a super long winter and total ecosystem collapse. And our iridium would still make it into the geological record. The effects are largely the same. The only difference is the root cause. So, is an asteroid or volcanoes to blame? There is evidence showing massive volcanic activity during the late Cretaceous, before the supposed asteroid hit. Researchers say that the presence of flood basalt corresponds with 3 out of the 5 mass extinctions, including the one that killed the dinosaurs. Flood basalts are left behind when massive areas of land are rapidly flooded with lava. They leave behind step-shaped igneous rock formations called traps. The Great Permian Extinction our alien friends witnessed in the last video was triggered by volcanic eruptions that would later form the Siberian Trap. Some scientists think the same thing happened to the dinosaurs and left its fingerprints in the Deccan Traps in modern-day West India. Data shows this region was highly active at the time of the dinosaur extinction. A violent eruption would have had far-reaching global effects, filling the atmosphere with dust, toxic sulfur and carbon dioxide gases, causing a wipeout in a similar way to the asteroid theory. Indeed, supercomputer simulations have shown that there is an incredibly strong correlation between flood basalt events and mass extinction events, much higher than pure chance. However, some scientists don't think it is an either-or situation. A growing body of research is trying to reconcile a both-and version of events, suggesting that the impact of the asteroid and the subsequent earthquakes potentiated the ongoing volcanic activity, taking it over the lethal threshold and into mass extinction territory. But the extent to which each event played a role is still up for debate. I hope this exploration of possible theories is enough to satisfy our alien scientists. By now, they've seen Earth in enough of its forms to know that if there is one thing they can rely on, it's transience. Earth won't be a ball of fiery rain and eternal winter forever. It's just a matter of time before life springs up again. Who knows what they'll see on their next flyby. Thanks for watching. I hope you enjoyed this 3rd chapter of Earth's planetary evolution. Are you interested in learning more about Earth's history in future episodes? Which part of Earth's history would you like to visit if you could? Please let me know in the comments. In the center of the arid and ancient supercontinent Pangaea, thousands of miles away from the sea, our time-traveling aliens have returned to witness a key moment in Earth's history. As they arrived, the rain began to fall. Just off Pangaea's west coast, in what is now Canada, epoch-ending volcanic activity sent off a chain of events that all but made this downpour inevitable. It would never look the same, because this was the start of a rain that wouldn't abate for over 1 million years. A rain that changed the course of life on Earth. A rain that allowed the dinosaurs to take over the world in an evolutionary coup. What's all the more surprising to me, and to our aliens who witness life on Earth develop, is that the kind of event that caused this rain is, ordinarily, the most reliable and powerful extinction event the world has ever known. But this one was different. One that takes the butterfly effect to its limits. Imagine, if a butterfly flapping its wings can cause a tornado 1,000 miles away, what does an eruption 100 times larger than a supervolcano cause? I'm Alex McColgan and you're watching Astrum. Join me today as we discover how an extinction-level event 230 million years ago increased the richness of life on Earth and accelerated the evolution of the dinosaurs, learning as we move through Earth's major cycles how burning fossil fuels contributed to climate change way ahead of the Industrial Revolution. What came before the rain? Pangaea was the largest continent that has ever existed on Earth by a long way, a record not likely to ever be beaten given it was the size of every current continent combined. Its huge size meant that the centre was far removed from coastal climates and therefore received very little rain, favouring the evolution of species that required less water to survive. During this dry period around 300 million years ago, in the Carboniferous period, several species emerged that are still important today, including dragonflies, millipedes, and spiders. Throughout this period, the diapsids also exploded, a group containing lizards and snakes as well as archosaurs. Now, you may not know that name, but you certainly know what this group contains: crocodiles, birds, and yes, eventually dinosaurs. But we'll come back to those later. If you've seen our previous episodes on ancient Earth, you'll know that it was a tumultuous and unforgiving place, with impending threats left, right, and centre, and above and below for that matter. While asteroids smashing into the crust better grab the attention of Hollywood, it's under the crust where the real danger has always been, and it's here that we will find answers to what caused a million-year storm. We live on a vanishingly thin crust that is so shallow that if the Earth was represented by the entire Lord of the Rings book trilogy, the layer harbouring all the known life in the entire universe would be confined to just one single page. Beneath, hot plumes rise up from the core, mushrooming as they rise and pushing molten magma up against the thin crust. These huge plumes punch through the crust wherever they meet it, completely ignoring continental fault lines where Earth's modern volcanic activity is concentrated, like the Pacific Ring of Fire. These plumes can release magma at the surface for over 1 million years, in what are known as flood basalt eruptions. It is these eruptions that are linked to the most incredible extinction events during Earth's history, and are probably the cause of the most destructive extinction event in history, the Great Dying, where ocean temperatures rose to 40 degrees Celsius. Despite life's ability to evolve, it is estimated that over 99% of every species that ever lived on Earth have gone extinct. Of course, you can't exactly evolve out of the way of a Mount Everest-sized asteroid travelling at 20 kilometers per second, but these volcanic processes, though slower and far less dramatic, can cause far greater devastation over a longer period. Evidence of flood volcanism is scattered across the world today. The eruptions of these flood basalts result in the creation of huge, unmistakable swaths of land, like the Siberian traps in northern Russia, the Deccan traps in western India, and the Wrangelian large igneous province across Canada and Alaska. They are all cooled flows of basalt rock kilometers deep, making them over 100 times larger than supervolcanoes. When we date these flood basalts, we see that many of these eruptions align with mass extinction events. There is one though that doesn't. That is our Rainmaker event that triggered the so-called Carnian pluvial episode, or the time that it rained for over 1 million years. It's believed that volcanic activity in the Wrangelian province is responsible for this remarkable transformation of an arid desert into an oasis that jump-started the dinosaurs' explosion. So what separated Wrangelia's eruption from the rest? What made it different? Well, I've got news for you. Size does matter. Although this was an extinction event with around 30% of the ocean species wiped out during the CPE, Wrangelia's eruption was just the right size to give life an overall boost on Earth. So the reason that the overall biodiversity was unchanged is because the level of extinction was matched by the emergence of new, exciting species more suited to this wetter world. What our aliens witnessed was less an extinction event and more a reinvention period. So how can slow eruption affect such an incredible change to Earth's climate? To understand how this transformational event shuffled the deck of life on Earth is to understand something that we are living through right now: climate change. Specifically, the release and production of carbon dioxide and the release of stored methane. Eruptions like these directly release carbon dioxide already contained within the mantle, but they can trigger its release from other stores too, from a source of carbon I thought only humans had used: huge reservoirs of fossil fuels. Now, whether you remember the fire triangle from school or not, fuel, heat and oxygen, I think we can all appreciate that introducing 1600 degrees Celsius magma to the base of untapped virgin coal beds is going to get spicy. Burning these crude coal beds would have released incredible amounts of particulates and greenhouse gases, both important for driving cloud formation and rainfall. Just as we are seeing today, the increasing levels of those greenhouse gases trap more of the sun's energy, and that energy has to go somewhere. So where does it go? Earth systems work to distribute that energy, and the one best place to absorb this extra energy is the water cycle, which becomes supercharged. The sun's energy is absorbed by the land and sea, evaporating water from the surface. Once in the atmosphere, the water can be carried great distances before precipitating onto land and returning to the sea along a meandering route. The more energy that is trapped by greenhouse gases, the faster the water cycle turns over. In these flood basalt eruptions, we see an extreme example of the complex interplay of the three major cycles: the geological, carbon and water cycle. The formation of the Wrangelian Large Igneous Province would have released huge amounts of CO2. Our alien ship detected atmospheric levels exceeding 1,000 parts per million, 2.5 times what they are today, increasing temperatures by 3 to 4 degrees Celsius. This supercharged the water cycle, greatly increasing evaporation and cloud formation, and these clouds were increasingly able to deliver rain further and further into the center of Pangaea. Throughout this period, the Earth became warmer and more humid, a dramatic change in the climate. Species that had adapted to a particular dry climate, environment or niche before the rain were put under stress from multiple fronts. During this turnover period in Earth's history, our aliens watched as old niches were seemingly destroyed as quickly as the new ones were created. The status quo was changing. Not only that, but species had to cope with a pH shift too. Carbon dioxide wasn't the only gas released by the Wrangelian eruption. Hydrogen sulfide gas erupted into the atmosphere along with it. This egg-smelling gas reacted with oxygen and water to form sulfuric acid, which in this form is more well known as acid rain. As the rain fell, the soils and oceans became inundated with acidified water, which only further contributed to the environmental stress some species were facing. Interestingly, a large amount of amber can be found in the geological record from the Carnian. Amber is a protective mechanism for trees that they release when in peril, suggesting that plant life came under significant stress during this period too. The incredible volume of rain across the supercontinent resulted in deluges of surface runoff. Accelerating across and through the arid terrain, these slightly acidic flows eroded the land as it went. Some of this acidic water seeped into and eroded small fissures in limestone and dolomite rocks. Our aliens watched as rocks were literally dissolved in front of their eyes. Over time, elaborate new cave systems were formed, like Britain's Jurassic caves carved from Carboniferous limestone, which provided yet more unique habitats for life to exploit. Eventually, the flow reached the sea, carrying the eroded rocks and minerals into the ocean, further nudging the coastal ecosystems into new territory. The ocean species were particularly hard hit, and large areas became anoxic, meaning they lacked oxygen, and highly acidified, which was not suitable for the existing ecosystems that inhabit those areas. Species like conodonts, ammonoids, Crinoids and green algae suffered particularly high extinction rates during the CPE, as did reef builders, while dinoflagellates, a constituent of today's ocean planktons, thrived. On their ship, the aliens moaned in disbelief every time the ship's AI forecasted the ongoing miserable weather. But back on land, one of the oldest known dinosaurs, Herrerasaurus, was braving the elements and roaming the earth. Some 6 meters in length and weighing more than 300 kilograms, it was an outlier prior to the Carnian pluvial episode when smaller reptiles and mammals were far more numerous. Its home was the Ishigualasto Formation, a volcanic floodplain defined by its dense jungle in what is South America today, a warm and humid environment which the Herrerasaurus was well adapted to. So when the rains began to fall, it won the geological lottery as its habitat spread across Pangaea. Advancing deeper into the continent, Herrerasaurus was greeted with literal oases, untouched habitat that with the extinction of herbivores and other competition meant it was to be a boom time for the Herrerasaurus and similar dinosaurs. We can only imagine the variety and richness of habitat available for all these wandering species to find and exploit and co-evolve with over time. Further away in the Dolomites, the aliens saw herds of large dinosaur creatures roaming the plains, and their wandering footsteps have been recorded deep in the rock. Across a 3 to 4 million year period spanning the Carnian pluvial episode, dinosaurs went from not featuring at all in the fossilized footprints to ecological dominance, making up over 90% of fossilized imprints. A remarkable takeover that agrees with other records in other parts of Pangaea during this time period, notably the Central European Formation and the Ishigualasto Basin in Argentina. The 2 million year period spanning the Carnian pluvial event left its mark in indelible ways, forever changing the trajectory of life on Earth as well as the passage of water across and through its surface. The mega monsoonal climate featured 4 distinct downpours, each carving a trace through the landscape, making the biblical storm that remade the Earth in 40 days and nights look more like a typical British summer in comparison. But the 5th period of rain never came. Once the Wrangelian eruption finally slowed, the emission of greenhouse and acid-forming gases slowed, and it is likely that levels of carbon dioxide fell as it was consumed by the rich flora that covered Pangaea, some of which would again become buried and form coal fossil fuel deposits for us to use today, continuing the carbon cycle. Now the storm has passed, we can answer our question. If a butterfly flapping its wings can cause a tornado 1,000 miles away, what does an eruption 100 times larger than a supervolcano cause? Well, a complete terraforming of land, sea, and air. The aliens left, having witnessed the origin of the dinosaurs' dominance and a remade Earth. Some of the 180 million years after the extinction event that gave dinosaurs their big break, another would strike, wiping them from the face of the earth. For the earth giveth, and the earth taketh away. From that point, it has been the mammals who have come to dominate, including us humans. A remarkable reminder both times of how much can change on a geological whim, but that at each time of asking, as the rules change, life adapts and goes again. Thanks for watching. This video was in part made possible by all the Astrum Nauts on Patreon. If you think these videos add some educational value to the world and want to give them more stability than the algorithm, you can become a paid member on Patreon to contribute towards their creation. When you join, you'll be able to watch the whole video ad-free, see your name in the credits, and submit questions to our team. Just sign up with the link in the description. Once again, a huge thank you from myself and the whole Astrum team. Meanwhile, click the link to this playlist for more Astrum content. I'll see you next time.